that tab. Hopefully, it's 2021, but we can always still say, can you see my slides? If you can see them, then thank you very much for coming along to Knots IoT. There is a code of conduct in place, and we do take this really seriously. So there's a lot of words there, but it really boils down to just be nice to everybody, be respectful, ask questions, and feel free to ask whatever sort of question you like, so long as it's a respectful one, of course. We like to think that there's no such thing as a silly question, so everybody should be comfortable to ask any level of question that they'd like to do. If you feel like you're not comfortable with someone's behavior, then you can either contact me directly through the Zoom chat, or you can contact me on Twitter at Pete_codes. Either of those two places are fine, and we will take that seriously and anonymously follow up on that to make sure that everyone's comfortable. But with that, we'd normally at this point be sat in the Rebel Recruiters office, and in fact I know that we have Ben here who works for Rebel, as it happens, and they're a fantastic local recruiter. But being as they're not paying for the food and not paying for the location, then they're not currently our sponsors, but I still like to call them out because they're fantastic. And when we go back to in person, I'm hoping we'll be able to go back to their lovely office in the middle of Nottingham. Without them, then I work for my company, PJG Creations, and so I tend to just put them as a sponsor on there because, I run the meetup, so you can't stop me. But Tech Nottingham, who are a fantastic local tech meetup and group, they sponsor our Zoom license. So we like to thank them, and I'll show you a link to them later on. And JetBrains, they sponsor us a license, which I'll mention in a second, and stickers. They sponsor our stickers that you can't have because we're not in person. So that's the sponsorship part there. However, there's no point anyone doing this because Alan Buxey always wins this, but there's a chance for you to be able to win a 12-month subscription to any one of the fabulous JetBrains products. If you don't know what JetBrains do, they make developer tools for developers. So things like ReSharper, IntelliJ, WebStorm, PHP Storm, all of those sorts of cracking tools. So if you tweet on the hashtag NotsIoT tonight, then over the next few days, I will pick a random winner and send you a code for a JetBrains product. We're actually running the Microsoft Cloud Skills Challenge at the moment as well. So there's only 3 days left. That says 24 days on there. This is when we first started it, but there's only 3 days left. So I know that I think Alan and Sander both have completed all of the modules, but what you need to do is complete 5 modules or more in a learning path that I'll give you a link to shortly. And then you'll be put into a draw to win either a Surface Go 2 and keyboard and a Bit plush toy. And I think that whole thing's worth well over £1,000. So it's a really cool prize. The second prize is some Surface headphones too, and I think they're a couple of £100. So again, really good prizes. And then the third prize is a Bit plushy toy. I think actually the hardest one to come by would be that Bit plushy toy, certainly being as I think they're sitting under people's desks in offices they can't get to at Microsoft. So I think they're the hardest, and I'm pretty sure that Alan Buxey is owed a Bit plush toy at some point when Adam Jackson from the UK DevRel team can actually get back to his office. He'll start sending those out. Complete 5 or more modules, and then you'll just need to tell me who you are on Learn and get in touch whichever way you feel you need to, and then we'll put you in a draw. The link is there, that aka.ms link. So go ahead and go to that, register on MS Learn. I mean, if you've never been on there, then this is a fantastic reason to go and check out the MS Docs and Learn site, which is an amazing resource for learning pretty much anything you like. But I've created a nice IoT path for you to go through there. Sander, you immediately leapt to the top of that list because I know you'd already completed all of those modules. So that was quite funny to watch. So there's that. So tonight we've got Sarah Masten and Alastair Davies. Sarah is from Microsoft Project 15, and Alastair is. I mean, I was hoping that I did all of this, and I didn't even ask you, but you did send me links to your profile. So Alastair is from Aribada. Is it Aribada? Is that how I pronounce it?
It is Aribada, yeah.
Perfect. The Aribada initiative. And they're going to be speaking about everything IoT and ecology. So I'm really looking forward to, IoT, AI and ecology, more to the point. So I'm looking forward to that. Coming up, I'm hoping that we've got Andrei Podnosov next month. We've spoken about him coming, but he didn't answer my email when I sent it to him yesterday. So it might just be a picture of him in some silence for an hour and a half. But theoretically, we'll be talking about Azure Digital Twins, which I know for Microsoft is a big push at the moment. And I'm pretty sure that Sarah will have a few things to say about digital twins during her conversation as well. So that should be a good one. That'll be Thursday, the 20th of May at the same time. On Monday, the 26th of April, we've got Liam Wesley talking Little Fluffy Clouds, which, to be fair, I can't quite remember what his talk was about, but I like the title because I liked the orb back in the day, and I think that's where that title comes from. As Alan mentioned, myself and Cliff Aegis, we run a little show on Twitch on the Azure-ish Live channel called IoT Live, and we just talk on a Tuesday night at 9 p.m. about everything IoT that we've spotted, and we have the odd guest on there as well. And then on a Thursday lunchtime at 2 p.m. BST, as it is at the moment, we often have live end-to-end solution stuff. We had Benjamin Carbe come along, and we did, as it happens, an Azure Digital Twins set up from start to finish with a LoRaWAN server, a Things Network server sitting up on an Azure virtual machine and some devices and stuff like that. So that was over 3 or 4 shows. It's all on YouTube, so you can find that on YouTube there. But do tune into that. That's on the Azure-ish channel, and we also stream live Azure stuff fortnightly on a Wednesday, is it, or a Tuesday? I can't remember now, at 12:30. And if you're interested in learning about IoT, then the AZ220 exam is a fantastic place to go and learn about that. And myself and some other authors have created a bunch of Pluralsight content you can go and watch. I'm also a member of a podcast, the Agile Engineering Podcast. Go and check that out. And as they're sponsoring us, fantastic Tech Nottingham, go and join their really cool community on Slack. They have got channels on there from everything from regular programming and whichever language you like, all the way through to just counting up in hex, whatever you want to do on your spare bit of time. They've got something for that. And with that, I can look at that. I've got 2 minutes to spare. We can do the virtual laptop switching around stuff. And Sarah Masten can start talking about Project 15. So thank you very much.
Let's see, Sarah Masten can try to figure out how to share her screen. Let's see. Here we go.
You've had one practice at that earlier.
I know. It doesn't assure. Hi, Mike.
Oh, that's
all right.
There you go.
Yay. Okay. This is always fun. Hello. I'm super excited that Pete invited me. We got to actually do the all around Azure, I think, in the same batch, which was a bunch of training around IoT based on something called the Event Learning Path, which is out on GitHub. So if you are going in for the AZ220, really, really good resources out there to learn all that stuff. I'll do a plug. It's aka.ms whack IoT LP, and you'll find some good stuff out there. All right, so I am here today. I am the founder of a project at Microsoft called Project 15 from Microsoft. And I thought I would come here today and tell a little bit about the origin story, what has happened since its founding, and a little bit about, where we're going. And so a little bit about me, and I think I have my thing in front of my thing. Okay, there we go. It's fine. So it's a little about me. I am a senior IoT solution architect at Microsoft. Pete asked me, where do you sit? Because Microsoft can be very complex with different orgs and different people, and we all work together. So I technically sit in a group that works with the Microsoft partner ecosystem to build out global scalable IoT solutions. And normally, that involve, smart refrigerators or smart cars or anything like that. I'm helping do that. My specialty is on the process architecture and data architecture side. So I work very well with my more devicey colleagues. So once the data actually gets to the cloud, I'm one of the people that can come and cook it and do all sorts of interesting things. And so my other hobbies include, I have a 9-year-old son who is homeschooling, so you might see him come running through. And then I have a problem. I don't think it's a problem, but a hobby of Legos. But I'm told it might be considered a problem. And keeping up on my sci-fi reading in the pandemic, which is a thing. So Project 15 actually starts with my cat. I know there's one person in this call that knew this cat. Unfortunately, she passed away this last year because she was older than this picture would imply. So this was Thomas. She looks incredibly cranky. And there's a reason. This was the day after we had a fire in my building. And so it was a Saturday night, and I was standing over here, actually, and I started to see a lot of smoke. So much smoke. I've never seen so much smoke in my life. And I panicked, and apparently I decided that I would run into the smoking building to save my cats. You'll see Dennis keeps coming up on the table because he's never in this talk, but he was there too. And the bell hadn't gone off yet. And I ran up all the stairs. I lived on the top floor, threw them into the cat carrier. Everything was super stressful. And then the bells started going off, and we got outside. And about 20 minutes later, the fire folks came in and said, "Oh, it's fine, go away." The next day, I saw the guy who runs my building, and I said, "What was that? I've never seen so much smoke." And he goes, "Well, I don't know why you ran up there. I mean, the fire was out for 20 minutes. By the time, your bells went off, I went, what?" And then he said, and by the way, it was as far away from you as possible." And I went, "I'm sorry, what?" And I kind of freaked out. And there's a cartoon character, Looney Tunes, Yosemite Sam, who gets like, "Oh, Rassaf, Rassaf." I kind of did that. And I just, there needs to be a way to tell people that, it's a false alarm. I could have broken my neck. My cats were frightened, blah, 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 blah. And he actually said to me that he goes, "Well, you're the one that builds that stuff. So, I'll buy you a coffee because you seem upset." But anyway, that led to me going and building something called Project Edison, because the day after the fire in my building, I was sitting on Microsoft's campus, and there was a terrible event at the YouTube campus that day, where there had been a shooting there. And I just had this idea, because where I was sitting on Microsoft's campus, which is huge, I don't know how many of you have been there. I know we were talking about Bellevue and the MVP summit and everything, but it's pretty big. It's the size of a town pretty much. And if something had happened on my campus, I could be sitting very far away from it and not know, and just be getting alerts that were very confusing and stressful. And then everyone I know could be messaging me worried. And then with that much information, it can be so confusing. So with the POC, and this was actually the pitch that got it funded, was a smart bulb. And if you could geocode the smart bulb and set up a radius of awareness, you could have something happen like a fire or anything else on the campus. But you could say, "Hey, only within a certain radius, they're turning red. But within an awareness radius, you turn yellow." And you could have a meeting, your meeting room has a light bulb, and you say, "Oh, something has happened. Now I'm not in immediate danger. I'm going to go look and get good instructions on where to go." And of course, something happens closer to you, you can do your safety drill and get out of there. And a year, about 9 months after that first drawing that I made and got it funded, a partner of ours built it, Project Edison, with us. And then they built out a commercial solution on top of that idea, which was called Connected Safety from Insight. It was deployed in the Houston School District. That's one of our bigger school districts in the United States. Houston's a pretty big town, so that was pretty exciting. And that was April of 2019, which feels like 10 years ago now, but it wasn't that long ago. At the same time that released as a commercial solution deployed, I met a guy named Eric Dinerstein. And Dr. Dinerstein had designed a camera trap. And so we were talking, and I was learning about a camera trap solution, and he was teaching me about anti-poaching. And so essentially he had won a grant from the Leonardo DiCaprio Foundation and AI for Earth over here at Microsoft, and worked with Intel to build this camera trap. So I was learning all about this. And I went to the cafe next to my house with my colleague Daisuke to hang out. And this is actually the first drawing that I drew. And I said, oh my God, this is a Project Edison solution. It's the same use case. And I never had thought about it. And I had gone on a tour that year talking about safe retail, safe factories, safe this, safe that, anything safe. I was talking about it. But I had never thought about safe parks or safe animals or anything like that. But it was a population that couldn't defend itself. It was a person or event that you're trying to stop or make less impactful with a device. And then there were people you needed to talk to get help, in this case, the rangers. And so we drew this picture and then I kind of ran around Microsoft a little bit. Because if you could apply Project Edison to anti-poaching, what was the real difference between shoplifting a shirt or a sweater from a big store and shoplifting a pangolin? And this is actually the most poached and trafficked animal in the world, these are very fascinating little creatures. So, I sounded like Chicken Little. I'm going, oh, hey, I think we can help the scientific developers because we have stuff that we just need to learn their use cases. And to my boss at the time, my skip level boss, we were having lunch and I was telling him about Eric and we were talking about Houston and all these things. And it was 12 noon when we started lunch and it was 12:45 at the end. And I said, it's an enigma problem. And he's like, what? And I'm like, well, do you know how many elephants died today because of poaching? And he said, no. And I said, well, 3 since we sat down to lunch. And he went, okay, whatever you're doing, just go. And I said, okay. And so we proposed and got support to build a video and a website. And to us, this was a type of phone where we didn't know what would happen. We reached out to, folks like us on the technical commercial side. And in the beginning, we had a website that had a lot of logos for friends of Project 15. And so a lot of great partners and a lot of great, hardware manufacturers put their logo on there saying, yep, we're here to figure this out. And it was really exciting. And then we waited. And the first people that called was a group called the Zambezi Partners. And they're basically a group of folks that invested in an elephant corridor, and they wanted to build a solution to protect it. The second folks that called was the Red Panda Network, and really fascinating. I didn't know. I learned so much through this project that folks that are in that area, like Alastair, are very generous with their time to teach myself and Daisuke as we kind of ramped into this new set of use cases and learning. But there's only about 2,500 red pandas left, and they're in the Himalayas. And the system that they had in place was very manual. Sonam, who runs the Red Panda Network, he trains the local villagers to go up and do observations, and then he collects that data and he has some camera traps, but they're all manually collecting the hard drives, etc., and then being able to manually tag them. So it's a very, very slow process. And then our third phone call was the United Nations Development Program. Daisuke and I could do a few projects in our spare time and nights and weekends because Project 15 has never been our day job. But when the Small Grants Program, this is the GEF Small Grants Program, which is implemented by the United Nations Development Program, Yoko Watanabe is the global manager. And when she called and said, hey, we heard about this, we'd love to bring your commercial processes into our world to get to scale, because this is a woman who runs an organization that has currently over 3,500 projects. And they range from biodiversity to urban sustainability to land, you name it. They're on the whole spectrum of sustainability topics. It's probably not the right word, but pillars of sustainability, if you will. And then she's got about 25,000 that go into the past. And how do you scale into that many projects? And so, it's almost an experiment that we did over the past year with them, where they gave a few projects and then we met with them and we would sit down and do our architectural design session, which means that, the architect from Microsoft comes in, we listen, we draw what that looks like on Azure. And we do that for our commercial partners in my normal day job. So we just kind of did the same thing. And as we kept meeting these projects, I started to learn that, there were a number of different buckets that scientific development projects seem to land in that kind of cause them to stall or not go as big as they wanted to. And, one of them was a catch-22, and Zambezi was in this bucket. And we've met a lot of people where, I'm heavy on data science and machine learning. I know what to do with the data, but I don't know how to hook up a whole system to get more data. So, because when you think about IoT, it's really plumbing to get from, and I come from a data warehouse background, so it's, the ETL portion of a big data warehouse, system is really that plumbing. How do I get from here to there? So that was one, which is kind of a catch-22. I can get the grant to work with my data. How do I get new data? Another one was POC devices. We've met people who are making really, really fascinating devices, but they may not know a full holistic cloud-based solution. A small fish, somebody who perhaps, maybe they are outside the granting model in the sense that maybe they're not academic, or, perhaps they're young, like all sorts of reasons why somebody is not gaining access to this, or doesn't, nobody's paying attention to them or something. The pit of financial despair, this is the original spirit of the Project 15 video, where you're using your grant money to reinvent something that already exists, but we just don't know each other. So that was the original spirit. And then this showcase idea, maybe a company kind of used it as a showcase, but after that was done at an event or something, like the project kind of stalled out. And then the myopic build, I don't know how to scale. And there's a slide somewhere at Microsoft where this is the same number and category, although different words, of why just every solution can get stalled or fail. So that we found that really interesting, that it was just the same. So around July, the Microsoft Hackathon, Microsoft has a company hackathon where we get a week off to, everybody puts up projects and people can sign up for people's projects. We decided that we would create an open platform. And because the more Daisuke and I would meet with these NGOs and different scientific developers, the more we realized that it's always pretty much 80 to 90% the same. And it's too much to learn every single bit of building an IoT solution. It'd be much easier if we just built it and put it out there. And then someone can come and learn, the last, bit, the use case that they need to customize it to. And it's also a lot easier. I mean, that's how I learned a lot of stuff in my career, is that, you're borrowing code and then you're tweaking it to do whatever you're doing. So it kind of followed that more natural learning curve that people follow. And it would also just accelerate development. So we put this out on GitHub. It is push button deploy, and I'll show it to you in a second here at the end. Daisuke wrote it, and this is the digital twins, Pete, that you were mentioning, because about a month and a half ago, maybe 2 months ago, I don't know, it's like 3 months pass in like a COVID day to me. So it was a couple months ago, I said, hey, when digital twins got relaunched with the graph based, I said, hey, let's put let's put digital to, let's rebase this so you have a choice. So when you spin this up, you can choose true or false on the template. Do you want the digital twins version of this? And within 10 minutes, you will have a fully fledged infrastructure that is digital twins enabled. All right, so we did this. This is a slide we use when we're talking to a scientific community a lot about it, because the spirit of Project 15 was really, what can you do to help? And what we could do to help is that we can just write this and put it on GitHub and help people get further faster. And so that was really our motive. And the other thing is that we are running out of time. And so by making this kind of stuff, and there's lots of stuff, that people could also leverage at Microsoft, like IoT Central, using stuff like that can really get you going faster. And that's what we really need to do, is get going faster. And then we can't let them fail. And so one of the things by doing this, it's, what happened during the pandemic, as you all know, as your IoT folks, a lot of you, is that people who do IoT got very, very, very busy, because we had to start landing solutions for ourselves for survival and getting back, touchless things, all of that. So to find someone that knows how to do an IoT solution developer type, that's super expensive if you're running on a business model that has granting in it. And so by doing this, it opened up the door to a community of developers. A, you can do the open source development. B, academia can come in and help. And C, you could get a more general developer who wants to learn IoT. Here's a great opportunity without having to learn it from the ground up. And so this is one of Daisuke's slides from his presentation I put in here. So when we were explaining what we were going to do with the open platform, especially with our partners at the UNDP, it's kind of like, you don't build a car every time you want to go somewhere or buy a car. You just kind of jump in, customize it, and off you go. And so same thinking. So this is what it looked like on a high level. Everything in green, and my apologies. I keep putting on my list to make little patterns because I know some people are colorblind. But the dark green is, or as my colleague would say, the darker brown, is stuff that needs customization, but it's included. And the lighter green, or as he would say, brown, is that, it's fully included, very little to do there, and you can kind of get up and go. And that blue part is, as we know, where our special use case goes. And this is what you will find out on the GitHub. So this is the actual Azure services that are involved. Everything in red, which again, if my colleague was here, he'd be like, Sarah, and I'm like, I'm sorry. So I have to change the colors. But those are not, they're not in the open platform. However, we've been doing a lot of things recently where, and I'll tell you about them in a minute. And if you're interested, you can come watch a show on Earth Day with the Reactor with Pamela Cortez and another developer advocate called Max, where we talk about a few things where these bits and pieces have been incorporated because we've been landing projects through our academic partnerships at Microsoft. One thing that I released recently, and you may have seen it if you're on my LinkedIn, and everyone join, invite me to be friends with you on LinkedIn. I love LinkedIn. It's called the Project 15 Challenge. And matchmaking, we've been matchmaking projects to capstones through the Microsoft Capstone program. That's probably a talk within itself. Spoiler alert, Earth Day, Reactor talk. But it's also, that's slow. And although that's a great idea to get really, really smart, like these are students who are, senior, doing their final thesis and graduate level students, it's a 4-month engagement. It gets things forward, but how do you do things at scale? And so one idea was this Project 15 Challenge, and we piloted it with University of Oxford. And so what it was is that you could have an NGO And the NGO can say, here are some use cases that, here's a background on my topic of study. Here are some use cases we've never been able to solve. And okay, a professor can come and build a semester project about it, or someone can do a hackathon topic, or anybody who's looking for something to do can go look through and say, oh, well, I'm going to go hack on this for a little while. Who knows? So that was really the spirit of that, and how to open up some of these use cases that are really, really hard to solve. I reached out to the Elephant Listening Project, and they were in. Okay, this sounds cool. So the elephants speak in something called infrasound. And what infrasound is that I'm going to have a picture in a minute, but it's sub level. So we actually can't hear them, but because the wavelength is so wide, it can travel up to 5 miles, and they can hear it through I think their feet. I don't want to get that wrong, but it's really, really fascinating how they communicate. And it wasn't discovered until, I want to say, about maybe 30 so years ago. And I might also get this wrong, but I believe it was a scientist named Dr. Joyce Poole, that discovered it in the first place. Of course, the elephants would say, discovered it? Ha! Anyway, so that's where it's way down at the bottom of the spectrum there. And, biologically, biological males can only hear in that spectrum there, and biological females can hear the top spectrum. And all I can think of when I saw this picture is there's an episode of Big Bang Theory where they're cleaning Penny's apartment, and like Sheldon is like, talk down here because women can't hear us, whatever. And that's all I could think of when I saw this picture, when the professor over at Cornell was teaching me about infrasound for the first time. I said, oh, I guess Sheldon is right again. So these were the use cases. And, demographics from these sounds. Gunshot detection has been a challenge. Determining if there's more than one animal's call. And that's an interesting one. I'll get to that in a minute. And if they go out of a grid. And so these were, this was basically, that was the Project 15 challenge. It was strange, because usually if you go to take a class at Oxford and it's the AI class, you think there's an answer. And if there was no answer, it was okay too. Any failure was considered a success. What happened, and I'll just share this, see if I can get this to share. All right, there we go. I'll bring it over. There was a group, all 5 groups landed solutions that were IoT based and using ML. Group 4, team 4, came up with a way to automatically count elephants in the sound samples, which had never been done. So the spectrograms, they only were able to do if there was 1 elephant or 2 or more. And then this project happened, and they put it out on GitHub. And so essentially, it's just really, really exciting, because, oh, and there, see, Dr. Poole. What was really exciting about it is that, sort of the background story is I was talking back and forth with Peter, who's at the Elephant Listening Project, and I, kind of brokering the questions, and all of a sudden he, I was like, a student group has a question, and he said, just change their parameters from this to this. And I said, okay. So they did that, and all of a sudden they got hundreds, if not thousands, of whisker graphs suddenly. And then I told him, he's like, oh, get them on the phone. So it was super exciting, because this work can then be brought into everything else that anybody who's studying in that area can do. So it worked. And so the Project 15 challenge, if you go out onto our GitHub now, you're going to see a very incomplete, because I'm still working on it. You're going to see a folder here. And as I talk to more NGOs, it's not entered yet, but we will be able to put, more and more, and hopefully people can come in, join, contribute, and with the model of, this is how this is going to work, and you're going to be able to give, here's your topic. See, broken links, how embarrassing, but I'll go with it. Growth mindset, that's what we call that at Microsoft. But you'll be able to take this format and submit their own use cases to hopefully get some of this done at scale. But yes, so this is the open platform that you can go out and if you go to deploy, there's a lot of words here, but it's written for somebody who's not necessarily technical to be able to read it, understand what it is, and then maybe pass it to someone who's going to be able to double click into it. As you keep going, it gets more and more complex. And then Daisuke, writes very, very complex documentation as you get in. And of course, it's linked to everything on MS Learn and everything else. But once you click deploy to Azure, it's if you don't know anything about Azure or Azure IoT, hopefully, and we love feedback, you're able to kind of get through this and just get going. So that's Project 15 and the open platform. Ta-da! I don't know how to there's a thank you slide normally, but
that was really good.
Yeah, fantastic.
I mean, the fact that it's all open sourced, it kind of speaks to what Microsoft are going in that direction as well. But as you said, to give this to people, it's the stuff that people could do with this is amazing, really, and hopefully help, which is kind of the main point, isn't it?
I guess. I mean, we are. I'll speak for myself, but Daisuke and I mean, we just didn't. We didn't know if it would work. We didn't know if people would think it was, put out a video and they're like, oh, what are you doing? Whatever. We had no idea. We didn't know anything about this area except being a concerned citizen. And then, as I learned, I've been on a big learning curve for 2 years now, which has been really exciting and awesome. And I know this topic can sometimes be overwhelming, or we're humans and we live on this earth. And so when we see things that are going on, at least this is how I felt before, is that it was so overwhelming and I didn't feel like I could help. But through this way, Daisuke, first me, Daisuke, then it spreads, into more developers oh my God, we can help. And then it becomes more hopeful. And so that we try really hard. And by putting it out there, it was just the easiest way, for scale. And then, a lot of organizations now, kind of, hey, we can really use this. Yeah, plumbing, and so it's really resonated, which has been really great to be able to just help.
That you showed the architecture diagram partway through that, and that really speaks to how much you've accomplished in that the platform, because I don't think until I'd seen that I'd realized how much plumbing. I mean, we've all seen the IoT reference architectures and things like that, but until you see these things up close and personal, you don't realize how hard it is to start plugging those things together. I mean, you mentioned IoT Central, which is also fantastic. And I guess there will be the potential for a solution accelerator for IoT Central, but the use case is different, isn't it?
Yeah, there's always a need. And to be honest, IoT Central can do things now that when we start, it didn't have all the cool video stuff they released recently. And there are reasons to choose PaaS versus, you're doing something with Central or, whatever you're doing. You're always going to have that choice. And so, especially if you're starting to integrate in with, something that you're doing perhaps with machine learning and, you maybe have a huge architecture there or something. So there is a lot of stuff now that can help with this. And if you go out to the Azure IoT and sustainability webpage, so that's the Project 15 webpage no longer exists, but you will see Project 15 on this sort of bigger Azure IoT and sustainability website. You'll see that, as eventually there'll be some partner solutions there as well, like there are on the other solutions pages. But you'll see a lot of those. Most of those are IoT Central, like water monitoring and lots of stuff there. So depending on where your area of focus is, you're given the same choice as commercial solutioning. We just kind of replicated it into this area that way.
I think they're going to fix the problem I'm just about to mention, but sort of the inability to bring your own services to IoT Central is one of the reasons why some people wouldn't choose IoT Central. I think, although you can export your data out and then out to an event hub and do what you like, but obviously your one is going to spin up the actual services for you to be able to pick and choose, like Lego bricks, if you will, to be able to plug them together. And
yeah, and honestly, I mean, you could. I'd have to figure out how to do it, because I'm just thinking about it. I'm like, I mean, there's parts of this you could spin up, and if you are already on IoT Central, like, you'd be able to do that data pump into it. So I mean, because the open platform architecture is PaaS, if you want to add Central to us, fine, good, yes, do it. And then you're just bringing it into your data layer and et cetera, et cetera. So yeah, I mean, that would actually work. That now I have an idea. That's how it happens. What was said recently to me, I'm a basket case of ideas. So yeah, no, but now I see some of the things coming to Central since last July, and I'm like, oh, cool, okay, great, even better. Like, these are even clearer choices to accelerate solutioning. So yeah.
I've monopolised Sarah's time just there. Has anybody else got any questions? I've got all the questions, so feel free to come off mute. By the way, I just muted everybody while people were speaking. Well, Sarah was speaking, so obviously feel free to come off mute or put it in if you don't feel comfortable doing that. Let's stick it in the chat.
Sarah, hi. This is Rohan Kamath. I know we are exchanging mails on the side. I was just wondering, in terms of being able to integrate it with more and more devices and device partners. I know you said there are multiple solutions anyways, but it does seem to have, and this is not a question, probably more a suggestion or an observation, it does seem to have a lot of overlap with your Azure FarmBeats solution as well, which is from Microsoft, which is a Microsoft research solution. Because if not from a species standpoint, at least from the environment monitoring standpoint, it does seem to have. So I don't know if you want to have a look at that as well to be able to expand the reach of your solution.
No, yes, I know FarmBeats very well. And so, kind of when we did this, like, FarmBeats is very, very heavy, and in my understanding on, they're doing a lot of interesting stuff with the wideband, or I'm using the wrong words, but the TV for remote farms and agriculture, and getting it very machine learning heavy, etc. So yes, I mean, I could see you could probably combine different ideas. If you're more device heavy, we kind of did it this way. It's basically going to land on the developer and what they want to choose and what they're comfortable with.
I've not heard of FarmBeat before, so I've just put a link to that.
Oh, it's super cool.
Yeah. I wish I had more.
But at any rate, I think it's a fantastic initiative. And I wonder if you're also looking at any sort of corporate partners to be able to utilize some of their, what is known as CSR, corporate social responsibility hours or effort, to be able to help you out in expanding this platform, because I think it's a very worthwhile cause, and it could be expanded a lot.
Yeah, it's a good point. Thank you, Rohan.
Any other questions? Silence. You've stunned them all. Is it? I've not looked at it in great detail, but is it all ARM templates? Is that how it's spinning everything up under the hood?
Pretty much, yeah.
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 So it's super easy.
He always tries to keep it under 15 minutes. But it's down to 9. I think it's 9 minutes.
Wow.
And he also has it wired up so that you will get a dashboard. If I should have thought he was going to come in on this meeting as a surprise guest and he could do a demo, but now it comes up and you actually have a full blown like it has Azure Maps and it has a test, you can simulate device. He also created it so that you could connect the Raspberry Pi simulator that's out there.
Oh, perfect.
And it's like automatically connected to play with this. It's not a pretty UI,
We're developers. We don't.
But
do
it works, right?
That's what it needs to do.
I'm tempted to spin it up if it only takes between 9 and 15 minutes. I've got like £10,000 worth of Azure credits to use up, so
Yeah.
And that's the other thing. It's optimized to be, I think it's under, if you're using everything on it and you're running it and you're just kind of building out with your first few devices, it's under $100 a month.
Wow. And it's got streaming analytics and TSI in there as well, so that's pretty impressive.
Yeah.
Okay.
Yeah.
The
So you can spin that up while Alastair talks,
Well,
I guess.
I might do that.
Yeah. You
Exactly,
could.
and I'll show people what that looks like at the end. I didn't know if it was worthwhile playing the video that you briefly alluded to there. It's only 3 minutes long, so as long as Alastair's okay waiting
Yeah,
another
of course.
4 minutes, then I'll put that on. I'll share the screen. There.
We lose one elephant from the planet every
Recognize that
15
voice?
minutes. We will lose all elephants in 10 years. It is that statistic pushed me into action. 15 minutes. The issues we're having around preservation, nature, and what I've learned is that scientists need help and they're running out of time. Project 15 is about building this bridge between the scientific community and the technical community so they can learn what tools we can bring to the table.
The Serengeti is one of the largest parks in Africa at 17,000 square kilometers, yet the Serengeti only has 150 guards. Imagine trying to protect the state of Maryland with 150 rangers. It's impossible. We started on Trail Guard about 4 years ago. It's a sensor put out in the field that can detect poachers and stop them before they kill. The first ones were successful. The problem was that our camera system sent every image, and that drained the battery really fast.
By listening to him, I learned that a solution that I had designed applied, and that was a safety platform called Project Edison. His camera sent events. It was the same as anything we did in a city, and that was my aha moment.
Sarah talks about the idea, and I said, I know how to do it.
We started drawing boundaries and where we could put devices and how that could all be brought up to the cloud for better notification of rangers.
We built Azure as a hyperscale cloud services platform. We're able to provide machine learning, analytics, or reporting all over the world.
Microsoft is really advancing these deep neural network models that are able to identify any species that is of concern to conservation.
We have a truly hybrid platform. I can run the same services that I have in the cloud down at the edge.
Microsoft's been dedicated to environmental sustainability for a long time. We have this culture that says if you can invent a technology solution to that problem, you should do that.
Project 15 can really have a bigger impact with something I already know.
There's a breadth of challenges that need to be solved. There's connectivity, networking, there's devices to be built.
One idea is to use the drone and the AI, and with this solar cells, we can cover big parks in Africa with the self-charging drones.
These are the kind of ideas. There's animal preservation, climate research, water purification.
We are looking for contribution from people with different technologies, skills, experience. Everybody can contribute.
Whatever you are interested in, take 15 minutes just to think about it.
How can the solutions you're developing be reimagined in the pursuit of solving some of the world's most critical challenges? Join Project 15 and bring your ideas to the table.
Please join us.
Join us.
Join us.
Please join us.
Awesome. Really good. I like that video as well. Powerful video. It's good. Recognise a couple of the people in it too.
Yeah, I know Lucas Joppa.
Okay.
He's
Yeah,
fantastic.
he used to live over in Cambridge in the UK and worked at Microsoft Research. This is probably about 13, 14 years ago. I used to hang out with him then. Then he moved over to the US and then has been a huge part in the whole kind of initiative over at Microsoft to push sustainability. AI for Earth is his big thing as well, right? So great to see him behind Project 15.
He's great. And if you go out to the Microsoft sustainability page, there's been, this past year, he's done a lot of like really cool videos that teach about circular economy, that teach about, the different pillars that Microsoft is focusing on, which are water, waste, energy, and CO2, and then ecosystems, and of course, Farm Beats and Project 15 and AI for Earth. Although AI for Earth falls across many of these with the data, like that's kind of where people think of them in this ecology bucket, at least for Farm Beats and then what we're doing. So it's really cool if you go out there. There's a lot of information. We've made a lot of big announcements around water this year. It's really good stuff if you're interested in that.
Yeah, definitely.
I had a question on YouTube, as it happens, from Ananda, asking what the best storage service is for Azure for IoT telemetry. I've suggested Cosmos DB, of course, but I didn't know. Actually, we're talking more digital twins. Oh, he was talking more digital twins there. So I'm not sure if you've got anything different to that. But
you're probably going to go Blob or Cosmos, depending on what you're doing, or you're going to put the time set on Cosmos to then push it down into the data lake or something. That's I agree with your answer, Pete. But I would also say for cost, potentially Blob, and then or you're doing something with Stream Analytics and perhaps you're storing it relationally. It's a whole nother talk about data landscape stuff.
I've just done a project and the client specified they wanted SQL Server in no uncertain terms. So they've got quite a lot of data stored in SQL Server that's very slow to query. So that's a good reason why you don't use SQL Server. It's just not made for lots and lots and lots of data. Just depends, like Sarah's just said, on what you're storing there. Ananda. So hopefully that answered your questions. If not, then do feel free to ask more in the YouTube chat there too. I've started spinning up that infrastructure. It's doing something at the moment. So yeah, most of it's already deployed. Actually, it's already deployed, most of it. So that's pretty cool. Pretty impressive. So, okay, with that, then we can switch across to Alastair, and he can talk about his work. Is it? You're going to talk a bit more broadly than just the Whipsnade Zoo stuff that I saw and collared you to come and speak about. So, I'm more than happy.
I am going to give you an intro to what I get up to, because I think it'll be interesting for you all as well. Really, I'm just going to get set up here. Usually I have to play around with the screen that you can see. Can you see which screen do you see here?
We see your speaker view rather than the...
Exactly, yeah. How about that?
There we go, perfect.
All right, so thank you very much, Sarah, too. Fantastic just learning about Project 15. I'm going to be in touch a lot more, I think, because you'll see in a minute how the world I work in connects to that. So loads to chat about there. But I'm Alastair Davies. I'm the director of an NGO, a technology NGO called the Arabada Initiative. And I'll explain now how I got to that role. So it all started when I became a Shuttleworth Foundation Fellow. You may have heard of Mark Shuttleworth. He's the chap behind Ubuntu who runs Canonical. And he has a foundation, the Shuttleworth Foundation, that supports individuals who want to basically give back and do something good in our world today. I got in touch saying there's a problem in conservation. Lots of that you saw from the other talk we just saw. But I wanted to look at open source hardware and software in conservation and how we can unlock access to it. So not just from the software realm, but how can we get hands-on working with animals, wildlife in the environment with hardware as well. And lots of that connects to the IoT world. So I created the Arabada initiative. Arabada translates to arrival. It's a word used in the world of sea turtles, when sea turtles nest at scale. So many thousands of them nest on a beach at one time. And that's where it started for me. I actually started creating sea turtle telemetry tags. This is on the island of Principe. This is the first turtle I ever tagged. So I was very nervous when I first started working on this turtle. It's an amazing experience because you get to work with a wild animal and a really quite unique animal, because when you work with nesting sea turtles, the spot where you're tagging the turtle will be the spot where that female green sea turtle will come back to 12 to 13 days later. So you get to work with that animal. In this case, we were putting a GPS log on. Here's a wonderful photo of the turtle. They don't always look that sad. This turtle had one of our wonderful tags applied to it. Inside there is a Nordic board. It's an NRF 52840. It's basically a GPS logger. We break out Bluetooth 5. So on the beach, you can connect to the turtle and download your data from the turtle as it's wandering around. It goes off into the ocean. We then collect GPS. We use Assist now offline. So it's the U-Blocks version, which means you basically preload the GPS with an almanac and ephemeris, which you actually need for difficult situations where the turtle's only breaching the water surface for a few seconds at most. So you need to have a good understanding of where those last GPS satellites were, so you can get a fast lock, save that data, and you basically repeat that on a duty cycle. The turtle comes back, you download the data, and it's a very cost-effective way of you understanding the spatial movement of the turtle itself. Here's another wonderful shot from our model turtle. And I started working on open source hardware to reduce the cost of doing this. If you wanted to do this today with a commercial tag, you're in the $1,500 per tag cost range for a basic GPS. And when you add satellite telemetry to it too, like Argos or Iridium, then you're in the $2,500 kind of ballpark range for a good satellite tag. So we really needed a way to achieve this. I also work with penguins down in Antarctica. And for this project, this was working with Penguin Watch, which is out of Oxford University, Tom Hart, the penguinologist. It is a true job title. You could have become penguinologists, everyone on the call. Unfortunately, we all went into IoT instead, but we could have done that in our lives. And here we're actually putting out cameras to watch the penguin colonies. So these are time-lapse cameras. And Tom was using off-the-shelf camera traps. So similar to the Bushnells and Reconics and the camera traps that are used today in the field. And he wanted to produce a lower cost open source camera. So we developed this one for him. This one is in South Georgia watching over king penguins. There are quite a few in the photo, as you can see. It's one of the best spots on the planet to actually observe king penguins, one of their strongholds in South Georgia. And inside that camera there, that's an off-the-shelf Peli case variant. That's a Nanook case. Inside there is a Raspberry Pi Zero. So we all know the Raspberry Pi. That's essentially a $5 to $10 device. With the standard Raspberry Pi camera, we put a hat on it, so an RTC hat to wake it, put it into a deep sleep, because you don't want to burn the Raspberry Pi power all the time. It's quite expensive in terms of power. You know, 70 to 90 milliamps is a lot if you're running off batteries. So we put it into a deep sleep with our hat. We wake it up, we take our photo, we go back to sleep, we rinse and repeat. Incredibly cheap to do that, because all you're looking at is a Pi Zero, the camera, your hat, SD cards and all of the extras. There's a bank of lithium-ion batteries in there, and that little red cable is to a solar panel. So we sit these out, we overwinter them in Antarctica, and we started scaling these now as an IoT solution. So lots of IoT products, from anything from sea turtles to watching penguins. And the very latest is actually an IoT water bottle. If my camera's still on now, this is the water that goes inside this. This is the water bottle that we put down the Ganges River in India and Bangladesh. This is one of them from the pack. So I've saved this. One day I'm going to crack this open and drink the water inside as a celebration. But we got a pack of these. We built this internal case to go inside. The GPS unit you see there, the little ceramic antenna on the left, it's the same unit from the sea turtle tag. We just repurposed it into a plastic bottle so we could track plastics. On the right, we had a cellular adapter, so we could send this data into Azure or any kind of service that we needed. And then we put our AA batteries on the bottom. And we took a load of these out to the project site in India and Bangladesh with National Geographic. It was their expedition, the Seed Source expedition. Each one of the tags was named after a member of the expedition. So we stuck a little sticker on there. We've got Amy, Heather, the whole team there. And it looked like this. So it's very much a floating IoT bottle to understand where plastics aggregate. And we also need to add satellite in there as well, because this bottle was going to go down the river into the open ocean, and we had to track this thing and get the data back. So we ended up with our IoT satellite bottle. We built an open source transmitter for the Argos constellation, the first open source transmitter of its kind. So now you can go and build your own solutions off our work. It's all on GitHub to go and have a look at. That's the little whip antenna there that you need for the Argos transmission. And this little bottle would float around on the ocean. And of course, when we deployed these things, we had no idea how far to go, where they'd end up. You know, it's a real interesting situation. But I do have, if this is going to play, a video of one of our bottles. So you can see where we deployed this. We were watching this back in London. So essentially the data was transmitted every 3 hours to the Argos satellites that went ahead. We used something called pre-pass. So there was a little almanac inside the bottle that basically wakes it up, checks for GPS, figures out where it is, and then locks it in a position that when the satellite's flying above, at that very second it passes at a 40-degree elevation, it'll transmit. So the bottle's aware of where the satellites are. And this little bottle did 2,800 kilometers in the open ocean. You can see it's aggregating there and it starts to circle around on itself. And it was a fantastic opportunity for us just to figure out where plastics moved. They traveled from Bangladesh all the way to the coast of India and started to swirl around in an eddy in this position. So we started to get a sense that plastics are aggregating in this way. And it's just another example of the kind of work that I get up to. This is going to end now. So moving forwards from that, now you've got a sense of the stuff I've been working on. Elephants, where do they come in? Well, we actually got an award from WWF. It was the Human Wildlife Conflict Tech Challenge Award. And it was for a solution to essentially develop an early warning detection system for Asian elephants, polar bears, and tigers. So quite a mix there. You've got the extremes of polar bears in the Arctic, you've got the heat of Asian elephants, and you've got the difficulty of tigers and all that camouflage and humid conditions trying to detect them. But we started with the polar bears. We got stuck in and went for the hardest subject. This is a Connex camera trap watching polar bears at a fence in Greenland. And you can see the amazing characters. They're sitting there looking through the fence, looking for food. And the problem is they'll basically break through, go into human settlements. They can smell seal skins, and they can smell rubbish from any, not just meters away, but like, a kilometer away can be detected by bears who will then go in. And that conflict event either causes the death of the bear itself because it's shot, or the death of a human if it's attacked. So our system was designed to detect these polar bears and give us a sense that we can create an alert. So we traveled to a Tokatumit. This is a Tokatumit. It's one of the most remote locations on the planet. A tiny settlement in East Greenland. And the way this worked is a camera trap detects a warm-blooded animal by a PIR sensor, passive infrared. So it detects a change in that heat. And that change is the presence of you walking past and breaking the beam, essentially, the detection area of that PIR. So you only get a 1 or a 0 from it. It's basically on or off. Take a photo, something's there, or don't take a photo. There's nothing else clever about it. You're really just using a Fresnel lens to break that signal out and then detect that change. So it works great for camera traps that just need to snap a photo, but then you have to analyze the photo. And the other systems you saw in the talk earlier are really now pushing the, the envelope on that, looking at can we process in the field from a photograph, run some edge AI machine learning and see what's in the picture. Well, we started to try and spin it on its head and look at doing that totally in infrared. So instead of us looking at an actual pixel image, we would look at the infrared version of it. And we started at first using something called a thermopile, which is basically a PIR sensor broken down into pixels. It's kind of the image there of a polar bear showing you how that represents. We started looking at, could we detect the shape of the polar bear in that pixel thermal image and get a confident check, so it's still Edge ML, and send that over a cellular or LoRaWAN connection or over satellite as well. Obviously, we do the satellite bottles. We could ping it back over SAT and then alert somebody who could come along, intervene, save the day, and it would be a system that would achieve the early warning alerts that we needed. But what we found was with thermopiles, if any of you are working in the IoT space, you may have seen this come up a lot in COVID detection as well, because there's been a huge push now for thermal sensors due to the pandemic to see if we can detect heat in humans and if that's an infection and so on. But you can see here the example of what thermopile does. The very cheapest Panasonic grid eyes, which are 8x8s, give you this 8x8 grid, which is far too low resolution to detect, with confidence what you're looking at. It's fine if you just want to see if there's a heat source. So great if you're looking at has an oven been left on, is a light on, etc. But too difficult to make up from a picture. But as you go up in resolution, you get into those 80x64s, you start to get a much better image resolution. This is an example of a thermopile running. So not bad at all, really, at 80x64. This is Hyman sensors in Germany. We started playing around with how you actually get even better resolution. So can you put an actual vacuum sensor on the end of the thermopile? So you're getting rid of air, which basically saturates the heat, which makes it harder for the sensor to detect you. So this is an example of a vacuum thermopile. But what we found too was the cost of the thermopiles, when you went away from the 8x8 up to the 80x64s, became a little bit too expensive for it to be economically viable at this point in time. So if you watch this video here, we started looking at what's the best way forward. If we're going to detect polar bears and elephants and tigers, could we actually do it with a thermopile? This is an example at distance. So as this chap here is walking around at 30 meters, you can see that you can still detect him. Kind of looks a little bit like the movie Predator, if any of you have seen that. You still can detect them, but at 30 meters, it was quite difficult. You started to lose that resolution. There was a lot of noise as well. So we're kind of still watching this space. We may still go back and look at this, but it kind of made us also look at what's called a microbilometer. And this is what a microbilometer looks like. You may have heard of these from FLIR. So FLIR camera traps are, not camera traps, but thermal sensors are some of the more well-known units. And a microbilometer had the range we needed to really get a sense of what our target species was. What are we looking at in the field? This is an example watching some deer with a microbilometer. And this is at like 100 meters. This is a 640 by 480 sensor. So the resolution you need was there. The problem at this point, though, was now the cost. For a 640 by 480 microbilometer, you're talking like $2,000 for a camera of this type. So we had to start to look at, okay, we can detect animals with this sensor. We can pull this data in, can process it on the edge, but where was the sweet spot between these technologies? So moving forwards, we started testing on polar bears. And here's 2 polar bears at Yorkshire Wildlife Park. This was a test just to see, could you even detect a polar bear with a microbilometer? When I first started this project, someone said, oh, it's impossible. Thermal cameras can't detect polar bears. They're invisible to it because they're so well insulated. That's not true. Here are 2 polar bears walking around being detected by a thermal microbilometer. But we found this out. We realized we could get decent range. And then we wanted to move forward with the project. So at this point in time, we've been out to Greenland. We'd tested the cameras. We knew that microbilometers were looking good. And we decided, all right, let's go now try them with elephants. So we worked with Whipsnade Zoo, so ZSL Whipsnade Zoo. This is an open source, off-the-shelf, DIY, build-it-yourself camera. It's basically running off a lepton, so a FLIR lepton sensor. I mean, you can see it really is DIY. We put like a little bank of lithium ions on the side there, the 18650s. Great little kind of off the shelf piece of kit though, because you've got the LCD screen there, so you can see what you're looking at. You press a little button on the top, it saves that to an SD card, and we started to log imagery of the elephants at various different angles to build a sense and to build our initial data set of can we detect them and can we run EdgeML on these sensors and build this early warning system for elephants as well. There's another little kind of zoom up showing you what it looked like. We started exploring the FLIR lepton. So it's an 80 by 60 lepton. It's the cheapest and smallest you can get. It was really interesting to see that you could detect the elephants. You can really get good profiles. You can see from a human's point of view, you can detect, or we can tell that we're looking at elephants in this scene. And then we knew that we had to move forward and start to train our models. This is the range of leptons you get. There's a 3.5 lepton as well, which is double the resolution. They stop at that resolution. You can't go higher than that. But from a cost point of view, it was quite affordable. So 165 is probably cheaper than that now for a lepton 2.5. But that kind of range was kind of in the ballpark of a normal camera trap. So a normal camera trap that you buy off the shelf, which is just using a bank of IR LEDs, would probably set you back about £200-ish, 200, 250. So we knew that we could probably make these thermal IoT-enabled camera traps that could process the FLIR imagery in the field, generate the alert, and send it back. So now we had to get back into the field and test this. We had to, go back to Whipsnade and say, okay, let's use these leptons at scale. So we needed a cheap way of doing that. So we took the Naturebytes case. So Naturebytes is a kind of company that I co-founded with two friends several years back to create Raspberry Pi DIY kits that you could use, build it yourself, put it in your garden, watch over bird tables, and basically get involved in wildlife conservation with your family. So you could build this around, the kitchen table on a Sunday afternoon. And we needed a waterproof shell to put our kit inside. Again, it's basically a Pi A+ in this case. We had a little kind of LiPo lithium ion charger from Adafruit. We packed that together, and what I did is I hacked it and put on a FLIR breakout board. So once again, we've got the PIR to wake the thing and say, hey, there's something in front of us. We've got the FLIR breakout board there. It just connects to the GPIOs on the board, so you can drive it that way. It's definitely not rocket science for anyone wanting to recreate this himself. So I took off the Raspberry Pi cam, replaced it with the FLIR, changed the material that we used to have over the aperture on the case, because with a micro bilometer, you have to have a different, it's called poly IR, but it's a different material to let the IR through so you can actually get a good reference image. And we built these cameras, tried them at Whipsnade, flew out to India and put them in the field in India as well. And here are some trial photos from Assam. And you can see we were, quite happily snapping photos of elephants moving around. And now we knew we had something which was tangible. We had the cost point right. We had a system which was easy to now build and deploy and move around. And we had obviously access to Whipsnade as well. So back at Whipsnade, we could really push this, take thousands of images. We took 30,000 in the end to build our model. And we realized you could detect elephants up to about 30 meters with a lepton before it just became too small of a resolution to get any more definition. We started to look at, could we try different resolutions? So, if you wanted more range, what would it look like if you had a higher resolution microbilometer? We're still exploring that to this day. So we don't yet know, it's active at the moment, if a 2.5 lepton or a 3.5 really does give you much difference, or if a 640 by 480 is even better. And also, what's it like in extreme sun and extreme heat? So obviously we're testing in the UK here a lot. So we need to figure out if it's working in the UK, great. But if we change that environment with a thermal sensor, what are those differences in the model? What do those images look like in 40-degree heat compared to, 20-degree heat, which is a very nice summer's day in the UK? So next steps, well, we got some great coverage recently on the BBC when we shared some of our footage. I'm going to show you one of the clips now. This is actually taken with one of our Seek thermal cameras. And these are the kind of clips we were getting of the elephants moving around. And And we kind of celebrated the fact that we got to 30,000. They were called selfies. The elephants obviously didn't take the pictures themselves, but it got converted into elephant selfies. But these kind of went viral, and there was great exposure around the work we were doing. And that's really pushed the project now, because it's quite, it's tangible. We've shown that you can detect the elephants. I'll show you a model now of it actually running. And there's a great kind of public participation now, because elephant conflict itself, elephant and human conflict, is a huge problem. So elephants lose their lives, as you saw in the previous talk too, due to just conflict events. So crops getting damaged, damage to property. These are issues that, for an elephant, you just want to get access to food. You just want to live your life side by side with humans. But when these events occur, it can have a really damaging effect on family life for the elephants. Loss of income is just, terrible for humans, because if you're a subsistence farmer and all your crops are trampled, that's food on the plate. So these wildlife conflict events, we need to get better at basically managing them. So better at early warning responses, better at getting involved, stopping these events from happening, mitigating them. So response teams need to know where the elephants are. Nearly all of the events where elephants will come into conflict with humans are often at night. So again, a thermal system works really well, considering we can see the elephants a lot further than a normal camera trap. And the model itself, so this is a TensorFlow object detection API model running on the footage that we get. And here it is detecting our elephants with a confidence bounding box. You can see sometimes it flashes for moments, it thinks it's a human, and it goes back to elephant. But this gave us the confidence that we can run this in the field. We can run our inference. It will be a microcontroller model. So we're going to have to shrink this down to run in the flash of microcontrollers. Been working with Edge Impulse on that. Don't know if you guys have seen Edge Impulse, but it's a really great system there running as well. And this is where we are right now. We're basically optimizing the model to see how small we can get it. Once we know we can run that model with a similar confidence, because there's no point in taking a 24 meg size model saying we've achieved it when we know we're going to have to shrink that down to say maybe 8 meg to fit in a microcontroller flash, and that's a big microcontroller. This is where we are. We're basically now optimizing this. I don't even think the comms part, like the LoRa and cellular, it will be too challenging. So we've already done a lot of that in other projects. The real trick of this has been, when do we release this model on a microcontroller as a prototype camera? And that's where we are right now, basically working to build our prototypes, tuning this model, still trialing the different resolutions of the system. And this will become an IoT, hopefully community-owned solution as we move forwards. It's all open source. And it was built with the elephants at Whipsnade, the fantastic elephants there, and the team in Assam. And hopefully this will go on to potentially even be linked to Project 15, and we'll see it, actually send its data through into that ecosystem. And it'll be another tool. So hopefully that was a nice intro for you all watching.
That's really good. It's exciting to see the role that technology can play. And I mean, people don't often think of just the conflict element that you were talking about, where people and animals are just coming into contact with each other, and it's not necessarily poaching that's causing the problem. It's just interference between two different sets of animals and people that don't really want to mix at that particular moment in time.
Yeah, and just scale. If you go back 100 years, it just wasn't as bad as it is. But as we grow as humanity and we take up more space, we have to get better at living side by side with wildlife. And I think technology just plays a vital part in achieving that, because it gives us an opportunity to understand where those conflict zones are. And it's not just elephants, of course, as you saw. Polar bears, tigers, other key species come into contact with humans, and it's often a deadly event due to that. Some of those species that are targeted. So we can get better at doing it. It's definitely not a saving grace. Just having an alert system doesn't solve the ultimate problem. Knowing that a target animal is around still doesn't save the day, unless you can do something from a response point of view. So have an actual team intervene, or have awareness. So if we send these messages, for example, over very common, let's say, social media, so WhatsApp alerts to a community group, or an SMS, or even an actual phone call generated that will phone you saying, you know, over in the kind of robotic voice style, there are 6 elephants approaching and they've, you know, been around for 10 minutes, just be aware. That could make the difference, but you need really agile system to do that at low cost for it to be scalable. So we really need to drop the price as well. Even the cost of camera trap now, it's okay, but we really want this to be, you know, $50 less really. And over time, we'll have to chase that to see where we get. But yeah, hopefully it'll make a difference.
A different problem, but it sounds a little bit like tsunami and earthquake warning systems, certainly tsunami warning systems, where you know, the faster you can make that alert, the more people you can get it to, and you've got to train people to react to it. Just the same with tsunamis, I guess. No good just knowing. You need to know what to do if there's a herd of elephants coming your way. You know, standing and shouting at them is not going to do you very much good.
Exactly. Yeah. I mean, another challenge is what can you do in the field and what can you do in the cloud? You know, so getting the data up into the cloud is key, because you really need to get it up there, so you can process it. Sorry, my kid is here. One sec.
I've got one of those.
She wants the password for a game. It's always the way, isn't it? Where's the password? So yeah, getting it into the cloud is great because you've got all of that, you know, compute space to process data, but you still need to do it on the edge. You still need to say, okay, I've got a lot of data on the edge. How can I shrink that down in size in just a few bytes, transmit that, go back to sleep, sit in a deep sleep mode, a few, you know, microamps of power, and achieve that. And that is still quite challenging. It's theoretically clean to do. We know how to get there. We know that you can get there, but it's sometimes hard. So you want to throw big ML models at these problems, and you can do that, but you still need to get your response from the field to that cloud, you know, system, process it and get it back. So I think there's still a sweet spot between how much do you do on the device, how much do you do in the cloud, and it's a learning process. You know, sometimes you try a system and then optimize it and change it, but I think as you're looking at, Sarah, the ability to do this quickly and efficiently will be key. So how can I just instantly try a different process? How can I pull in a different model, try it, see if it's effective or not quickly, rather than spending 6 months building the ecosystem behind it, all of the tool chain, realizing it didn't really do the trick, and you've spent 6 months of your time just, you know, playing with hardware and software to get that to work.
Yeah, I was gonna say, I mean, Edge Impulse is super interesting if you're not familiar with them. It's TinyML and it's low code, and you know, that's a really cool platform. And you know, I've been lucky enough to be brought in on a few projects that we worked on, like the Elephant Edge hackathon, and
Yep.
And so if you're interested in you know, low code, or you know, maybe you're like, oh, I'd love to get into ML, they're a really cool platform to get out there and work on stuff. But it is, I mean, it's the balance of the what's on edge, what's on cloud. It is exactly the same struggles as commercial solutions, actually. Like it's I think I've been hearing that for years now, where it's like, okay, and how much is here and how much is there, and then how are we doing this? As the devices on the edge are getting better and faster and stronger, like I think you're going to end up in a world in a few years where, you know, the edge is just like, hey, what's up? I can process all this stuff. And so I forgot what I was going to say, but the other thing that you mentioned was the cost. And so one of the, you know, that's really one of the things we try to do, at least on the Project 15 side, in the beginning, especially, where you see these devices and they're being made, you know, it's sort of, you know, you're making them custom, or you're do. If only I could get attention on this device. And let's say you're an NGO who's making a device, but that device could actually go into a catalog and kind of do that device pattern that devices that are in the commercial space follow, so that once you see that your device could be used by 100 different solutions versus just my custom one that I've been working on with my granting, bringing a partner ecosystem in that way, that a device manufacturer says, hey, you know what, we can make that, and we can put it in a catalog. And so, that's one of the things we've been doing as we work with projects and meet new projects. If they've designed a device, is making those matchmaking introductions where appropriate. But that's really like, I hope over time, it maybe Alastair's got this fancy device, but somebody who I'm think of a hardware manufacturing company like Seed sees this video and says, oh, interesting, we have a very similar device or something, and then it ends up in a catalog so that anybody doing that kind of solution is able to get it, and that mass production of it brings it down.
That's exactly it. One thing we've been looking at too is group purchasing, which has been really impactful. So we're on the call right now. If say we were all interested in solving a problem and we all individually all wanted access to one or two devices, we all go off and buy it. We all pay premiums. We're all just buying one of each. We all know it's costing electronics. By just bringing together communities of interested developers, conservationists, ecologists, practitioners in any way, and just saying, hey, let's all do it just at the same time. You go to someone like Seed or Group Gets or anybody else and say, well, we want to buy 500 in one batch. And it's great, because then we all basically join the batch together. We all get that low-cost device. And then it's open there, an open source software ecosystem where 2 or 3 people go off in a different tangent, maybe hack it a little bit and go and use it on a completely unknown project you never even thought it'd be used on. Everyone else has used it for the bread and butter, but you get that kind of evolution you want to get from it, which is you can get access to both the hardware and the software and get involved, learn from it, share on your code, share on your expertise in a way that everyone else picks it up. And we are starting to see that a little bit. There's a device called the Audio Moth, which has been really successful using group purchasing. And that's now, had a massive dent in the acoustic space. I also noticed there's a comment here saying, is there any advice for a software developer new to IoT that wants to make more of an impact when it comes to conservation and the environment? Which is a great question. So my advice there is actually software is still, there's so much need for good software development in IoT, in conservation. You'll see that there are a lot of hardware projects where people are chipping away, trying different ways of achieving, let's say, detection of an acoustic event, or potentially it's something like a new payload for a UAV, for a drone. You're trying to use that and get out there, and it's, hacked to a DJI device of any kind. The software world of it always needs support, because there's always that connection between, okay, I've now changed my entire kind of firmware on my microcontroller. It's something new because it has to be a new device which has come out from a different ecosystem. That kind of bridge between, okay, I've had something that worked in a completely different space, we know can be challenging when you're picking up a new tool. So if you've heard of Zephyr IoT and so on, there are new OSs that are designed now to work in the microcontroller space, but be a lot more adaptable, or like, MicroPython and so on, that's now become a lot more popular. If you get somebody who's just really adapted in MicroPython, who takes a board which supports it, you can, become a lot more impactful, because they can just get more done. Whereas if you're picking up, you never used it before, it can be a slow process. So from a software developer getting involved in IoT, just reach out to some of the, like Sarah and myself and people who are in the field playing with the hardware and say, hey, where can I get involved? There'll be loads that we can send you to say, here's a cool project, they're struggling with this, have a look at it. You may be, oh, I did that for 10 years, that kind of person. And then you're off, you're involved.
I was going to say, I now know a lot more about devices, but I'm going to kind of out myself. I know Peter knows, I know Mike knows down there, Elsmore. I didn't know anything about IoT when I got a job in IoT, because a lot of people may think, Internet of Things, it's hardware, but that software and data part, Daisuke, if he were here, he would do his introduction where he is very heavy on the device side for the last 20 years. I am heavy on the cloud and the data side. But those in the hardware side don't necessarily know anything about the software cloud data side, because their focus is getting that data to the cloud. And then they're going to go off and solder more things and make cool stuff. There are people that know all of it. Yes, Daisuke is one of them, actually. But at the same time, don't be intimidated getting started just because you think, oh, I don't know how to solder, or I don't know, chipsets or something. Like, you can learn chipsets, but the more you get involved with projects, especially if you go into open source, the more you're going to find that somebody doesn't know how to do what you know how to do, and you'll be teaching each other. So I do a lot of talks around, and we mentioned in the beginning, Pete, around the all around Azure. My module in that thing was about how IoT data is a new operational data set to bring into other data. And that talk is really, really fashioned towards people who are data warehouse architects, data engineers, not hardware people necessarily. And so we can post the link to those. He did it. You're Pete. You're just on it every time. But I was going to say, we have a whole philosophy I know a lot of people do, but at Microsoft, the growth mindset. It's okay that you don't know how to do that. And so I wanted to just speak up and say, I didn't know anything about that 3 years ago. And, it never stopped me from being able to design IoT platforms. I just made sure that I had a friend who could kind of be like, nope, that is incorrect. And this is how it goes. And that's fine.
We all need that friend.
Yeah. Nope. Reverse. But yeah, you'll find that a lot of people who are super good on the hardware really need your help.
We've got a bunch of other questions in the chat. I'm keen to sort of backtrack to some of them. I know, Alan, you asked, does the antennae on that bottle cause like a sail effect? It looked like pretty thin antennae, not too dissimilar to what you'd see on the front of a Formula One car. So I doubt if it was going to cause too much turbulence, a Formula One team would be happy sticking something like that on there. But it's an interesting question.
Yeah, it didn't actually. Yeah, it's the actual problem we had on that project was a tsunami and a typhoon. It was a really interesting project. When we launched that bottle, you see when I showed you the simulation, the path, the bottle was heading out south and it kind of got pulled back and then went back across to the coast of India. When we actually launched those bottles out, we had a tropical storm come through, and it was a big one as well. So the wave height when we were checking those was something like the swell was 9 meters in height. 9 meters is a huge swell. So even though you think the bottles are going to be affected by wind from the antenna, the actual current itself is so much more impactful than the wind alone. So once those currents swell up and the seas start moving, you can basically go on windy.com, which is an amazing simulator where all the currents are coming from. And you can predict where those bottles are going to go because you've got a sense of what those currents look like and you see them following. So we didn't really see too much of a drag on the antenna. I think it was mostly down to the actual current and just the state of the sea at the time.
Alan also asked whether a heat source has got a clearer signal when it's in a colder environment. I think you kind of answered that while you were speaking, didn't you?
Yeah, thermopiles and microbilometers like the cold. So if you actually want a cooled microbilometer, so that's actually actively cooled to get it down to like negative 20, 30 degrees C, you can get better performance from them. And they're really interesting to see. The military use them at that kind of point of view because you get really good performance. But it's not the problem. You get better detection in the cold, but it's the problem with some of those thermopiles and microbilometers running in the Arctic. They are still shuttered. So you have a little shutter that pops in front of it so it can basically reset itself and not let the image drift, because microbilometers need a little shutter to calibrate. The shutter comes down like every few seconds, pops back up again. And if you don't have that shutter, the image drifts and you can't get a good visual image back. If the shutter freezes because it's negative 40 degrees C, then you lose your microbilometer or your camera itself. So we're actually looking at the moment, is it possible to put some of those cameras inside cases where we then put a mini vacuum in, essentially suck all the air out, get rid of any chance of condensation, and then let that shutter to run for those extreme environments. Again, you can chuck money at the problem and get away with that and build, you know, a really great system that can do it, but we're trying to do it on the cheap. So we're going to have to look at how do you just do really cheap enclosures to protect them.
Cool. Alan's got all the questions, actually. He mentioned about shark detection would be another thing for like Australian beaches, which seem to have a trouble with that at the moment. Obviously, you've got to tag these things just like your turtles were tagged, I guess. And then he was obviously the flip side of that is poachers using this data for nefarious purposes rather than for good.
Yeah. Security is actually something that sometimes gets mentioned in this world of conservation, but good encryption or, you know, good practice in what Sarah and I are doing will be key as well. Because you can imagine any of the systems we use for anti-poaching can be used for poaching in the wrong hands if we can't understand how to manage that.
And I want to kind of, I know we're not traveling right now generally, but just kind of as a PSA, like as I've been learning about this and it kind of dawned on me, you know, once you're like, oh my God, yeah, no, we can't, you know, post a picture. You know, people will go see an endangered animal and they will not mean to, but they'll post a picture up to, you know, a social media platform and it has the metadata on it of where they were. And so it's one of those things that as I become more and more aware, meeting folks like Alastair and other conservationists, it's like, oh, right. So if, you know, if you're going out to go see whatever, you get invited somewhere, like it's really important to make sure that you're posting things that are protecting those animals that you saw. Because it is true. Like there is a bunch of bad folks out there that are trying to get at these animals. So we need to do our best.
Yep, definitely.
Yeah, and to go all the way back to the question that was at the bottom of the chat there for a minute, and Ander on YouTube was saying how hard it is to get a job in IoT as a software dev if you don't have any experience whatsoever. He's been trying for a year, in fact, to get a job in Azure IoT. I've suggested, obviously, there's things like going past the AZ220 cert and put yourself above other people if it's specifically Azure IoT you're interested in.
You know, let me speak to that. Yes, AZ220, that's a thing to do, true. And again, you know, go out and spin up the open platform and go through the tutorials out on Microsoft Learn. You may have and I think it's easiest almost if you have an idea of like a little hobby project you want to do. And I gave a talk about this a number of years ago on a podcast for someone who wanted to know how to switch careers. If they, you know, they always had experience in one area, want to move. And I said, use GitHub, like join communities or do something yourself. If I can see something that somebody is doing, that really makes the case to me, you know, that they're working on it, even though maybe the job is nothing but infrastructure or something. And I'm moving into data or I'm moving into something else. Like really use that and build yourself kind of an open source resume, if you will, of projects that are either you contributed to something. And hey, if you invent something and do a pull request into the Project 15 open platform and Dicecase says yes, I mean, those are things too. You can contribute to big projects and say, I added something. You can put that on your resume, and some of these bigger companies like Microsoft and others, the minute you do that, you know, we don't let everything in. So, you know, it's always add some weight to trying to grow a new kind of portfolio.
Yeah, definitely.
Definitely goes two ways as well, because, you know, not only have you've got the gravitas of something that you've made being accepted, but you've also learnt how to make that thing along the way, which is real. And obviously, is what Sarah's alluding to there, is that's real world proof that you can do what it is that you'd like to do. But not only that, but you have passion for it. And quite often an employer will see the passion before they'll see what it is you've actually done. If you're willing to, certainly from a Microsoft point of view, they hire on your fit and your growth mentality and your ability to work in teams almost more than your experience, because they can teach you experience, but they can't teach your personality and your ability to learn and things like that. So it's hard, and it's harder at the moment than it is for from a lot of times with the pandemic happening, but don't give up whatever you do, because as Alastair said there earlier, there's a massive want, and it's only going to get bigger for people that can program in and around IoT. And you don't necessarily need to know devices, as Sarah said. You can know Python and be very useful to people without even touching a device. So yeah, definitely well worth doing that. Sorry, did I cut across you there, Alastair? Did you have
No, I was just going to say, when we started this talk at the beginning, there was someone mentioning conferences, and the best thing about the conference is not the actual conference, slides and main presentations, but all those kind of beers with friends. Was it Alan?
Yeah, it was Alan, I think.
Yeah, so true. So in conservation, I've been to conferences where a week-long conference will be, I maybe go to 2 or 3 actual slideshow presentations in the day, because it's all about meeting everyone and talking about the projects. And when you find that the right characters and the right people, and you just get excited about trying something, then you're known. Your details are shared. You can move around. You can talk about the code you like to run, the hardware, and that's it. Then you're off. So that was really good, just mentioning that at the beginning. Really get out there and meet. I mean, you can't do it at the moment due to the pandemic, but when you can, do it, because if you want to get your foot in the door, so to speak, being a physical person and also not just always being digital does have an effect, so try and get to some of these events and meet the real people behind this.
Fair. Good points. Scrolling through the list of questions. I mean, loads of questions. Good. It speaks to how good the talks were. Leo Paul's asked, is wondering whether or not how data is pushed to server for further analysis. I'd like to know about the last point data transfer to server. I guess this was from your talk, Alastair.
Yeah, you could just do it with Sarah's as well. So the way that we did it was, when we first worked with those bottles, we actually used AWS. So I don't know if I'm supposed to say that because we're so as you're happy today.
We are agnostic. It's fine.
Yeah, we made simple HTTP calls. So we would actually send our payload in. We had to do it in as short as time as possible to save data on the cell connection. So we used the tool chain in AWS to achieve that. I would say at the time we did that because it was simpler to do. There was just a nice documentation to achieve that as well. So we went away and just set that up. From a LoRa perspective, or a LoRaWAN perspective, we often use a LoRix 1 gateway. So a very kind of, you can see a lot of heads nodding, a nice to use gateway with chirp stack and everything you need already embedded in there. And we use Bilometer boards. So I don't know if you've seen Bilometer, it used to be called Resin, now it's Bilometer. So really nice ways of essentially SSHing into your device in the middle of the field. You get the dashboard of where is my physical device. You can push a Docker container to it and just update all your devices. And we use that as our kind of gateway bridge to control the gateways. And from that point on, we then have access to a cellular LoRaWAN, or in the satellite case, an environment to work with. But the actual connectivity from those tags was just a HTTP call over to an AWS instance and straight into their dashboarding system. And we'd use the actual dashboarding system to get maps and visualization, which actually is just the way to do it, right? Because you don't need to reinvent that, just dashboard it. You just want to know, where's my thing? Where is it? What's it doing? What's its status? Use some device shadowing and off you go. So hopefully that's useful. Sarah, I know you may have a say on that too. Your
I mean, it's going to come in through IoT Hub. It's going to go. I mean, this will not sound like a totally different story, but you're going to come in. You can embed Stream Analytics up into a Power BI dashboard. You can use Azure Maps. If you want to go play with that, that's all in the open platform. But the open platform that we did is really just a bunch of Azure services strung together. There's no, it's going to apply if you're making a smart, I don't even know, lawnmower. I'm looking at my lawn because for me it's a very different time. 'Cause it's actually it's noon for me. But you're making something, it's sending the signals, you're doing things, and you're showing it up on a map, etc. So kind of the same stuff. If you're doing that on Azure, you're gonna find all the documentation on MS Learn and tutorials on how to get going doing that.
Awesome. Jake T has asked as well, how was the bottle returned? Would have thought it would have just sunk eventually.
So some of the bottles traveled about 50 meters and got stuck, and that was their life. We had names for them, as you could see. There was one bottle that traveled right to the edge of the delta, got stuck on a little island, and for the rest of its days, for about 9 months, were just pinging from the same spot. I was always hoping maybe one day it's going to get dislodged, but not all of the bottles ever make it into the ocean. Some of them get stuck and then they're recovered. We had one bottle stolen. We could tell it was stolen. It was a cellular bottle. And I don't know, actually, it was an interesting story because someone must have looked up the APN for that. Because someone opened the bottle, nicked the SIM card, put it in their phone. And we only noticed when we got a bill shock when we realized in our portal that there was like 100 megs worth of data use. So we thought there's no way that bottle can send 100 megs. It'd be impossible. And we didn't put a cap because we just didn't expect it to happen, because you needed to know the APN for the SIM. You had to actually put it in so it would connect to the network. Because if you work with cellular, the APN is important to connect to the cellular carrier. And we had a private APN. So unless they looked it up, I was pretty impressed that someone actually managed to nick it and actually use that SIM to do that. But anyway, we realized that when we got the 100 megs worth of credit, and it's roaming credit, so it was expensive. So that's interesting too. Other bottles get stolen and you see where they are because you get in GPS. So it's like, why is my bottle wandering around the farm? But then we had one bottle that went walkies and then got put back in the river. So someone probably took it for a while and thought, what the hell am I going to do with this? And decided, I'm probably going to, wake up in a cold sweat in the night thinking the police are going to turn up. So they chucked it back in the river. But the plan is those bottles can be autonomous. They can last a number of years if you stack them with the right batteries. Really low power cycles. So you can you're sleeping most of the time. You're only waking for a minute to do your job and go back to sleep. So they should ultimately end up on a beach somewhere, and you'll know where they are. We've had a few people say, "Can you make a biodegradable bottle?" Sarah, we've been mentioning this. That's basically, instead of making that cavity out of a new plastic, let's use recyclable plastics. Obviously, the biodegradable bit is you've still got electronics inside. So you're still looking at, okay, can the PCB be made out of like a biograde plastic? The batteries, of course, are batteries. So are they going to degrade? They probably will be. But you can still try and make enough of the enclosure to be as biodegradable as possible in case you never get it back and it's scuttled at sea. But it is an interesting challenge too. And it's one Sarah and I have actually been chatting about outside this, about what does sustainability look like in hardware? What can you do from a PCB enclosure perspective to make it as biodegradable as possible?
Yeah, things like ROS and Kosh and stuff, when they came in, which was, I don't know, a couple of decades ago now, probably, they all added to the help. Lead-free solder and things like that are all great. And then there's a disposal of equipment, sort of, I don't know what you'd call it, what that is now, but there's all sorts of stuff that people are doing. But yeah, you're right, something that can biodegrade in electronics. Certainly batteries are the biggest problem, I would have thought, out of everything you've just mentioned there.
Yeah, exactly.
It's interesting because once I've had my own learning journey as I get into the different aspects of sustainability initiatives in different ways. And so the hardware conversation is one that, once you start down that path, you're thinking about, even making better batteries. How do we make whatever? Then you get into even coding. You can do, there's a whole course on MS Learn. My colleague Asim does it. He's the Green Cloud Advocate, and it's fascinating, really, because if you go in and you rewrite your queries on a database, let's say you're a database person, if you're using less compute because you have you have written optimized queries in your code, you're actually writing more sustainable code that is then using less resources down the way. It's like this kind of this butterfly effect of, I wrote a terrible join and it, burned down a bunch of resources. Okay, but if you go through even your code and making it more succinct and more optimized, that is a way to be more sustainable. And it seems, once you start thinking about it, it's not trivial, but that's true, and it'll make for lesser bills. And nobody likes a runaway query, but your switch statements, whatever, like if you're looking for something to do, well, this week during my pandemic quarantine, I went and looked at a bunch of my old code and I made sure that now I'm a better developer. So I went back and fixed some things that are out there, etc. Like that's actually a sustainable engineering activity.
Interesting. I think we're gonna sort of talk about that on the podcast that we're going to record next week with you, aren't we, Sarah? To a degree, a little bit of that. But,
I don't know what you're talking about.
Yeah, no.
What? No spoilers. What?
There was what board or what tech have you got inside the bottle? I don't know if I missed that bit during your presentation there, Alastair.
I'll try and tell my kid. I can hear my kids upstairs. We're having a bath with.
Yeah.
So if you hear more screaming, it's sounds of kids not enjoying their bath. It's a Nordic board, so it's the same as the turtle tag. So it's an NRF 52840. We have a little adapter to the cellular or Arctic. So the Arctic R2 is the Argos transmitter that we use. So you can basically preload it. There you go. There's a nice link in chat there to that. You can basically use just the board on its own as a GPS logger, or you can add the cellular as a daughter board, or both. So you can have the GPS logger and the cellular and the satellite. We sell a developer's kit actually. It's called Horizon. So if you search for Arabada Horizon, you'll find the kit. It's all open source. You can spin your own boards up. And that in its own right was just a nice way for us to release hardware that could be quite useful for everybody, because you can get a board off us, or you can just basically make a hybrid where you've got cellular or the board itself if that's what you really want, or just satellite. So in the bottles, we only had the satellite module with the GPS board. Yeah, there you go. Thank you very much for Pete for sharing that. And you can track your own items, right? You don't have to just be plastic. If you're working for on an environmental project, you can track all manner of interesting things. We've got people looking at fishing nets, so ghost nets, which can kill a lot of wildlife on the open ocean. Someone's building some wooden trackers at the moment. So sustainability again, can we actually build this into wooden objects so we don't have to use new plastics or anything to do this? So plenty out there to get involved in if you're interested in telemetry.
I wonder, is Azure RTOS compatible with that NRF? That looks like a perfect candidate for Azure RTOS, that does, in the tiny devices category.
Yeah, it'd be interesting.
I like it. Well, so you're talking about edge stuff. Obviously, one of the trade-offs you have to make between processing at the edge and not processing at the edge is the power you were talking about. And obviously, any amount of AI you do at the edge is going to use a fair amount of battery. Things get hot when you do AI. That's just the way it is. There's things out there coming. Obviously, the NVIDIA Jetson, that gets hot, obviously, but that's a great AI at the edge example. I think is the Arduino Portenta, I think, isn't that going to be doing some AI at the edge? And I think there's, in fact, even talk of the next Raspberry Pi Silicon is going to have inbuilt AI as well. If Eben Upton's raising eyebrows of anything to go by on what the next iteration of the Pi is going to look like. So I think certainly, I think Sarah mentioned this as well, the drive towards edge processing is going to be massive in the future. And obviously, the more you can do at the edge, then the faster it is, because you've not got that latency, which for when you're doing stuff like we've been talking about tonight is mega important, because you could be sitting in the middle of a field in Africa with no connection other than a 2G GSM modem. So you kind of only need to be sending the data that you want to send on those but cost as well. It can be expensive. Although £100 a month doesn't sound much, when you scale that up, the numbers start getting quite big. So, yeah.
Most definitely.
Yeah, I was going to say, this, I forgot where the cover, this is just a random tidbit. But when Daisuke and I started, we were on a project, and I can't tell you details about that project, but I can tell you that we were very surprised when he was looking at the coverage map that, it had 3G, I think. And that's another thing to sort of check your assumptions at the door, in the sense that you may think that some place is really remote, I don't know, etc. It's like anything else. You could be like, whoa, wait a minute. Okay, hang on. I had an assumption that that place in the world didn't have anything but, whatever. Like, and so that's not actually true. Like some places actually are setting up infrastructure. And so if you have ideas, it's kind of one of those, bring them, because you'd be surprised at some of the advancements that are going on.
Yeah, certainly it was interesting. That was where the broadband is most likely going to be cellular in places like that. And so that drives that tech up. So they often have better cellular coverage than you'd ever imagine, because that is their broadband. They don't have the physical infrastructure for that. So they need to have 4G. And so certainly places like Africa, you'd be surprised, and India have very good 4G and cellular coverage because of that as a reason. Yeah.
What was the couple of the other things, like you may be thinking, oh yeah, I'd really like to get into camera traps or something. You're carrying, most people listening to this are probably carrying one, just using the phone, and that if you treat that as a moving piece of equipment, that's not a bad idea either. I've seen some really cool stuff coming around some of the work we've done with Project 15 and some folks, where it's like, oh, interesting, okay, stuff like that. So you don't need to, if you don't think, whoever it was that asked the question, I can't remember who asked the question about, I don't know much about hardware. Well, you're walking around with a very sophisticated IoT device, probably, if you're, have a phone. So those kind of, that's enough to start doing a POC. You can get the metadata off of those pictures. You can make, you can have it look at a river by your house. You can, stuff like that to start getting involved. I don't know if that's helpful, but I kind of thought about it where I was like, oh, right, the camera trap that's in my pocket. I use it mostly on my cats, but
you're right. Yeah. And also one comment here about software sims. I think software sims are going to be really interesting because, yes, it does solve the problem if someone nicks your physical sim. You have more control over it. But also MQTT. So this kind of new like NB-IoT, LTE cellular. The software sim bit of that means you can switch, right? You can basically decide where your data goes from here's a physical device in the field connected to a cell network, and then pipe it to wherever you want, because it's then basically software defined. Usually you have to then connect to the cellular carrier through their APN. It's then on their network, then you have to get that from them pushed to wherever you need to get it. If there's any issue, any block, which my experience when you're roaming around the planet on strange networks in unknown countries, if something goes wrong, there is no support person to call. It's just an unknown, company running an unknown cell network, and you're pretty much stuck. So when we get into that kind of shared world where we have more control over where that data is just going, like which service you're going to get it to, it would be a lot more easier to work. It's and cheaper as well, because it'll be ubiquitous roaming versus, the other way around.
Somebody mentioned Starlink as well as an opportunity, and obviously schemes like that. Starlink won't be the only company that launched microsatellites to be able to deal with this sort of a thing. So that will obviously help and maybe drive down costs, you'd hope.
I'll show you something on Starlink.
Ah.
1 second. Give me one second. I'll see if I can pick this thing up. So it arrived today. So this, I don't know if you can see this on the camera.
I can see the corner of a box.
You can see a corner of it.
Starling dish.
Oh, nice.
Oh.
Really
So, that only arrived today in the post. So I haven't even opened it, I just took it in. But you're totally right. When I saw that it was available, it's on beta at the moment.
Mhm.
For me, that's going to be a game changer for actual fixed observation. It's still some time to go until it's got total coverage, but that's going in my garden. And I don't actually need it. I've got broadband, right? I'm talking to you on fiber, but I'm going to build it in a way that I'll put a solar panel on it, get used to it, so I know its power consumption, build it as a rig, and that will go into the field in some completely unknown location. So we've got fast net, but it's great. It's 150 meg down and 50 up.
Yeah, it's impressive.
So that's amazing from the middle of nowhere. And I've been using satellite services for years in my conservation work. I'm used to like 0.50 up, It's like maybe I'll get a few emails and browse google.com.
Yeah.
Whereas now it's like, so that's going to be a great game changer. So I'll let you know how that goes.
I think it's what, 100 quid a month or something like that?
£90. It's $89. Let's say 90 quid.
Yeah.
But I heard today that it cost them $3,000 to make the dish, but selling it for $489, which because it's want to incentivize people getting on the network. Because when I saw it, it's self-detecting. You use an app with AR, so you basically hold it to the sky. It'll show you where the satellites are. I mean, when I used to put up dishes, I'd be there with a little kind of beatbox, like beep 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 beep, trying to get my millimeter, and then a bird would land on the dish and it'd detune itself. Now it's like it's automatic motor orientated with an app, and you're up in minutes with that kind of speed. Dream. The dish is small. I used to have like big KU band 2.1 meter dishes. This thing's like normal kind of SkySat dish, because it's so low Earth orbit. They're so near, we can get the signal. So anyway, I'm going to be having fun with that. I'll let you know how it goes.
Yeah, that's awesome. I like that.
Yeah.
I guess if you can put it in the field and you've got LoRaWAN as your local hookups for all your sensors, and they're able to communicate to it, so you've got sort of a radial distribution, that would be your single uplink then.
Totally. I mean, you've got so much bandwidth on this. You could probably have your really low data, like let's say IoT sensors, lots of them to your gateway, but also you can push something over time. So you could take some imagery, which was always very difficult to do, slowly push it over. I wouldn't do that over LoRa, but you could obviously do that over cell or anything else to an aggregated gateway, and you got all the bandwidth you need then just to push it back up. Whereas usually you'd be spending a lot. And of course, if you had 4G, great, but not everywhere that's possible. If you're on 3G or 2G, you're going to be way too limited. So yeah, just really great for just more observation. And just imagine like watching remote bird nests, Philippine eagles, birds which are just critically endangered in the middle of nowhere. You could get HD quality links to watch this. Live stream from nowhere. The only caveat is I've heard it takes 100 watts of power.
What?
So 100 watts of power in the middle of nowhere is a challenge. So even though it's got it, we haven't cracked that yet. So that's like, really you need some lead acid batteries, a 200 watt panel to mitigate for not perfect solar charge all the time. And that's quite big then. Then it's no longer like it's quite an install. So I can't fault it though at the moment. You still get the data out. Just means more solar panels.
You can do your edge processing at a gateway that's at that location and have all the other devices send data to that. You could have two-way comms back to the devices to send alerts out that way. But yeah, you could do all the edge processing there, couldn't you?
Or wake it, right? You could wake it for 10 minutes, transfer all the data you need, and go back to sleep for a day.
Perfect.
Just so you could basically trickle charge with a smaller dish and just use that. There's a lot you could do with it. Yeah. We'll do a talk once it's in the field one day. I'll come back on. We'll do a talk about where it went and what it's doing.
Brilliant. I like that idea. I'll hold you to that. Talking of which, I'd spun Project 15 up, your open platform. So that was dead quick. It's been finished for ages, but I've just been too busy chatting. So obviously we start on the Project 15 page here that Sarah showed you, and you just click this deploy to Azure link, and then that takes you to Azure and it spins your resources up, which, let's pull this down a little bit, spun up a whole heap of bits and bobs for me. And then the instructions then tell you to go and grab a post-deployment script that you need to run here in the Cloud Shell, which is what I did. And then once you've done that, then you can hit this address up, and that gives you this, which is the Project 15 page. And because this is all so small, that looks like that temperature's not actually changing. But trust me, there's a nice graph underneath that straight line. So that what I did was what Sarah mentioned. So there's a Raspberry Pi simulator here that I use all the time. It's dead handy piece of kit. And all you need to do is stick that connection string in there. So it spins you up an IoT hub, and you can go to your devices, add a new device, and then grab the connection string, and you can paste that into the simulator, and then that starts sending data. But one of the things that this Project 15 relies on is something called plug and play. To be able to plug and play uses digital twins design language, DDTL, to be able to specify the capabilities of a device. And without that, Project 15 doesn't know what your capabilities are, and specifically it doesn't know which of the bits of telemetry that you want to map are. So it asks you here to put that telemetry in, which you can get from the simulator. It's telling you that it's sending temperature there. I could have put humidity in. If you've ever done IoT and started out, you get temperature and humidity as your version of flashing an LED for getting cloud telemetry working. And once you put that in, then set the telemetry refresh interval, and then you get this nice graph which is coming out of TSI. There's also maps here, but we're not sending any GPS data, so it's not going to do anything with maps.
I was gonna say, yeah, it's Daisuke is actually highly involved with IoT plug and play, and so this from the beginning, it's ready for plug and play, and IoT plug and play is not that's not an Azure specific type of thing. There's a consortium, and everyone's sort of involved. So if you don't know what IoT plug and play is, it's something to go learn and look up, because if you think about your own PC experience or Mac experience or whatever experience, these days, when you plug in a mouse, it knows that I am a mouse and I have 16 buttons, only 2 of which you will use. But all of these can work and they do such and such. Back in the day, you would actually be downloading drivers, putting them in. Oh my God, I just updated Windows and now I have to go reinstall. I mean, it was a mess. But plug and play really solved that, late 90s-ish, IoT, same thing. So imagine a world like right now, there's still a lot of custom work that needs to be done if you're doing stuff with devices. But over time, you will wind up with, this device just kind of clicks into a system, and those things do exist. They're starting to come online for commercial type solutions. But I think IoT plug and play is a really interesting topic, and it's really just about making that file, the DTDL, that Azure Digital Twins is ready to, hey, I know what that is. You're in my system now. You're up on my graph, etc. But that's a really interesting thing, especially if you're on a device side. You're making devices, like it's a low hanging, put this file in here now, because in a few years, I'm pretty sure plug and play will take over like it did for us the first time around. So, yep. I'm sorry I ranted about it, but
no, that's not a rant.
I'm so into it, and I know that Daisuke was actually one of the architects of it earlier in his career, and so you think, he invented, what did he invent? He was very big in the invention of the USB drive driver. So every time you plug in a USB, you're actually using something that Daisuke. And so this platform is made by the same person. So there you go.
That's why I say.
Yeah.
Were you going to say something, Alastair?
No, I was going to say that I saw something funny on the internet last week. It was a triangular USB adapter, and it said you still need to try and put it in 6 times at every orientation to make it fit before it works, right? It's like, it's so true. Yeah, just it came to my head.
That's true. But Sarah's right about the consortium that Microsoft are a part of there, and certainly they're trying to lead. Someone who's made a really interesting comment where they could sit 5 different manufacturers of dimmer switches in a room and ask them to come up with a model for dimmer switches, and they would get 5 completely different models, and that's the sort of problem that you're up against, trying to get alignment with manufacturers on any form of standard. But if they can manage that, then it could become super powerful, certainly for digital twins, to be able to automatically recognize these, pull them into a graph, map them, and ingest data automatically without you having to do that lower level stuff. I know IoT Central have done, that team have done some fantastic work on plug and play. When you go in and have a look at new devices on there, there's a whole heap of them that do
you just go to a catalog and you're like, I'm using this, and off we go, and it knows how to simulate that, and that's something you can also spin up real quick as well, and just start to play with different devices that are in the catalog already.
Yeah, dead good.
It's really cool.
Not only that, but it's got built-in simulation in IoT Central, so you don't even need the actual device. You just need the device template, which, if you will, is the plug and play model for it. So it knows it's got a temperature sensor and a humidity sensor or GPS or all those different things and what format that comes in. And then you can just click simulate this device and it will give you some simulated stuff. It's really quite powerful, actually. IoT. I love IoT Central, and in fact, I'm a consultant, and I use that frequently because you develop on it, and you can give your client the platform and let them manage it because it's all built in. It's really, really great tool.
I was going to say, when it came out, I was on the IoT in Action tour, and when people, the analogy that I would use to people that weren't really familiar with it or what it was or anything, I said, hey, remember when you would make a web page and you'd have to know how to do HTML files and do and la la la, and then CSS got more standardized, invented, etc. Now you're doing that. Then you could hook up a MySQL database, so now you need to learn how to do that if you want to have blog comments. And remember how much that was really kind of difficult. But then WordPress got invented, and everyone wound up with a blog place and pictures and recipes. So like IoT Central to me, in terms of simplifying that, I know the word journey is used a lot, but in simplifying that journey, IoT Central to me, when I first learned about it, really was. I was like, wow, this is kind of like WordPress sort of situation. So if that's new to you as well, I mean, go check that out.
Links in the chat. I love IoT Central. It's dead good, and you're right, it's just dead fast. There's a 7-day free trial for 5 devices, but after that you get 2 devices free, and even after that, then it's 50p a device per month, and you get something like 400,000 messages to something ridiculous like that before you even start charged for messages. It's amazing because it comes with time series insights, Azure Maps, Stream Analytics.
It has all the connectors. If you want to go, hook up a Teams channel that's getting messages, you can do that pretty easily.
Export out to Event Hubs or Service Bus or Blob Storage, and then the rest of Azure's yours. It's super powerful, and make nice rich dashboards, and it's can't talk highly enough about IoT Central. I do like it. It's great. So I mean, I've rambled as well. Is there any more questions? Anybody got anything else they want to ask before we start this? I'm cautious. It's already 9:05, so
it's been lovely just chatting. It's nice to hang out and have time. Right? Sometimes you do these chats and you got half an hour. You just listen to someone with slides. It's great. We get to just chat. It's been great.
Definitely.
I still wish it was in person and I could have just come over.
One day soon.
An excuse to come over there.
Definitely. I was just going to show the services that it spins up, by the way, but it's a bit difficult to see. But I wonder if I maximize the screen, then you can see we've got event grid topics, digital twins, because I ticked the digital twins button, and DPS we talked about. Event Hub's namespace, a function app. Be interested to see what the code is in the function app, actually. I guess maybe that's for digital twins, those two things together, possibly. Again, app service plan for the web app that we got there, and Signal R. Interesting. Must be for the website.
Oh, you're going to have to ask Daisuke onto your show.
We most certainly are.
Double click. You'll be like, Signal R, what's up?
Yeah, Signal R's awesome. I've got a Raspberry Pi robot arm back here that I've got controlled, uses Signal R, and I've even made a Unity app for my Oculus Quest where I can move it from the inside there. Signal R is fantastic. Yeah, it's well worth looking at. Storage accounts, stuff like that. So there's lots and lots of boilerplate there that's been hooked up. And that isn't straightforward to do. It's not a minute's worth of work. You've got lots of Lego pieces with complicated connectors in between them. So the IoT Central is another version of this, but this gives you all of the services individually for you to be able to then take and use. So yeah, congratulations to you and your team, Sarah. That's awesome work there. So yeah.
Yeah, well done.
And obviously, thanks to Alastair and Sarah for the talks. Amazing, really great information. And I'd definitely hold you to coming back, because I think we could have another one of these and talk about an entirely different part of the same subject and find out just as much information.
We'll do it. Yeah, it'd be great. We can see where we are, see what new projects have gone into Project 15. I'll show you where I am at that point. And that'll be fab to do. Yeah.
Obviously,
love to come back.
We've done high level, so you can do a more in-depth hardware side of things and what's involved in getting that stuff to actually work. And I'm sure that people would find that very interesting.
That would be great, actually. You could do like an actual live walkthrough, setting up a Horizon tag from scratch, getting it, sending data. Yeah, that'd be lovely.
Yep, and likewise, Sarah, I'm sure there's a whole heap of stuff.
Yeah, we have some really good like project stories growing. We do go from this to this, it's been really exciting. I'll talk more about that when we meet in the future.
Yes, absolutely. Yeah, please, soon, hopefully, back to in-person stuff. End of the year, maybe. Although we've got our first in-person conference round here being organised for October. DDD East Midlands, Jess White and Morton Brockley are organising that to be in person. So do go and check them out. That should be a good event. But it's hybrid. It'll be hybrid.
I was going to, if I can, I'll share the link for the reactor event on Earth Day.
I've done it. It's up there somewhere.
If you want to come in and hear some stories, we will have some stories.
It'll be a busy day. I did share that earlier, but go ahead.
Oh, you did? Okay.
Oh, sorry. Yeah, no, but do it again by all means.
I know. I'm really excited about. I'm really excited about this talk. I'll be in it for a very short period of time just to like introduce, but then I just sit back and watch all the cool stuff.
There's like 6 speakers at it, including Pamela Cortez, who's fantastic. And
yeah. This is a good one.
I've signed up while we're online. It's on my wife's birthday though, so
it'll be recorded, I think. So
that was the day.
I mean, your wife's birthday. I meant you can watch. No, I'm kidding.
We've already had this conversation.
Don't. He probably will.
No, this was supposed to be on my wife's birthday at one point, and then I had to, grovel back to Sarah to say, just realised.
But what a fantastic present.
Yeah. Jeez. And yeah, so thanks to Sarah and Alastair for agreeing to come along and give their fantastic talk. So thank you all for coming along and listening as well. It's been great to see, and hopefully we'll see you all again in the future. Do keep in touch, reach out on LinkedIn and Twitter and places like that, and we can continue the conversation there as well. Don't forget to come back next month, which we've got a rather protracted length of time now because this is an early Knots IoT. So when did I say? 20th,
due to birthday debacle scheduling on Pete's side.
Yeah.
Okay.
But yeah, I think it's 20th, I said, for digital twins. So it's quite a nice segue, rather long, lengthy segue into that. So do that. Go and check out MS Learn and stuff. Do the AZ220 exam, all of those things. In fact, if you can do AZ220, you better be quick because there's a massive refresh happening on the 23rd, which is a massive pain for Pluralsight authors like me. But that's going to bring in stuff like digital twins and stuff into that as well. So and check out Project 15 and Aribad. Oh, geez, can't even pronounce it now. But
You did well, Arabada.
That one, and see what they're doing too.
Brilliant.
So, thank you everybody for coming along, and we'll see you next month.
Yeah, thanks so much for having me.
Thank you, everyone.
Thanks.
Cool.
See you later. Bye.
Bye.
Everyone, take care.